Hi! This instructional video is about factoring special product property. Special product property. This one is about factoring special product property that is difference of a binomial, or we call it difference of two squares. Let me show you how this works. First of all, you need to recognize right away that x squared, that's a perfect square. And 4 is a perfect square. So, how do we factor this? You ask yourself, here's a, what times what is x squared? You say x and x. What times what is 4? You say 2 and 2. Now you notice there's no middle term. The b is a 0, 0x. This can be written as x squared plus 0x minus 4 if you were to use an AC factor. So we have 2 and 2. Now, what must their signs be? So if you add it, combine the 2 and 2, it will become a 0? Well, one has to be plus and one has to be minus. And negative 2 times positive 2 becomes negative 4. So that becomes a proper factorization for that special product property, difference of two squares. Yeah, that's it. Why don't you try number 2 and 3? All right. So already you probably caught a pattern. What times what is 4x squared? You said 2x and 2x. And what times what is a 25? Negative. You say plus 5 minus 5. And let me actually do the FOIL method to show you that that is a proper factorization. First, 2x and 2x, they become 4x squared. 2x times negative 5 become negative 10x. Now, since this is opposite, 5 times 2x become plus 10x, knowing that that's going to cancel. And 5 times negative 5 is negative 25. And voila! When the middle terms cancel out, you end up with 4x squared minus 25. So in fact, this was the proper factorization. There's your proof. So number 3, you can see right away, oh yeah, and if you noticed, they're always minus in between. They're all perfect square. The A and the C, the A and the C, and the A and the C terms are all perfect squares, and they're always minus. Because one has to be plus and minus to cancel out the middle term. So here you have 3x, 3x, 8 and 8. And one has to be plus and minus, and you're done. Maybe not quite. So now why don't you try apply that factoring method of the expression and use it to solve the equations. Go ahead. Alright, you said number 1. Okay, I got this. Special product property. Difference. Perfect square. Yes, that's a perfect square. 1 times 1. Perfect square and perfect square. So we could just do this simultaneously. That's x times x is x squared. And you should know this one. 11 times 11 is negative 121 if one is plus and minus. And how do you solve it? You have to take each of those binomials and use the zero product property. Set it to 0, that is. Yeah. So when you subtract 11, this one becomes negative 11. Or add 11, so it becomes x is 11. 2 solutions. And this one? 7 and 7, x and x, plus 1, minus 1. Set each one to 0, zero product property. So when you subtract 1 and divide 7, x becomes negative 1/7. Or add 1, divide 7, x becomes 1 over 7. And finally, yes, they're all perfect squares. It only works if they are perfect squares. That one's 6x, that one's 6x. 9 and 9. And you need plus and minus to cancel out the middle term. So set each of those binomials to 0. And then when you subtract 9, divide 6, you get 9 over 3 negative, but you have to simplify. 3 goes to negative 9, negative 3 times. That means this is positive 3 times. That's it. All right.